Good afternoon. Long couple of days, a lot of great information. I'm Chad Albrecht. I'm going to talk to you a little bit today about Agile economics. This is a big deck. Before I talk a little bit about that, let me tell you a little bit about me. I've been doing this for way too long, over 20 years. I've worked in all areas of the business, and a problem that I noticed a number of years ago was that we'd have these Agile guys come in, we'd do these CSM trainings, or Scrum.org would come in and do some training, and we'd train the dev teams up, and that would work fine, and then things would fail after a while. And what I really discovered is that we weren't really looking at what the questions that the business was asking, which was from a money and economic standpoint, why should I do Agile? This deck has accumulated over the last 10 years. And it's the answer to that question. This is, well, hold on just a second. Before I jump into the width of this deck, for those of you, if you have friends in the Midwest in the coming weeks, reach out. We're doing a small ALM conference, two-day conference in Chicago on March 6th and 7th. Certainly pass the word out on that. 20% discount on that conference for attendees. So ALM Summit. So we're gonna talk about simple software economics, and then I'm going to actually show you a case study, a side-by-side comparison with a more gated method as opposed to an Agile method. And here's the warning that I've been just itching to get to, is that this is a big deck stuffed into 15 minutes. This morning I actually looked for a picture of an elephant stuffed into a little 5-gallon bucket. I couldn't find one, but that's what should go here. So fasten your seatbelts, because here we go. All right, so as we move through this first part, there's going to be a couple of indicators on the top of the screen. Red to indicate this is going to impact cost. Black to indicate that these things are going to impact revenue. What we're doing is really building a set of things to look at, a tool set for you to look at as you're analyzing different projects. The first thing that we're going to look at is something called utility. And this is, you're probably not familiar with this. How many people are familiar with the concept of economic utility? Anybody? Okay, so what you can think about this in this context is a best if used by date. What I discovered in working with a bunch of economic professors and kind of looking at what was going on in the market and some of the things that happen with projects is that there's a time period where features stay fresh, where they work well, and then anything past that date, they start rotting. What's interesting is if you look at Agile projects and you look at Scrum and XP and this desire to deliver 1 to 4 weeks, that kind of lines up with that freshness. You heard Dean Leffingwell talk about some quotes that we try to deliver fast enough where the customer can't change their mind. That's actually a quote from Esther Derby, I believe. Ironically, that's what we're doing here, is trying to deliver fast enough where these features stay fresh. All in all, these utility curves, these preferences for these features vary over time. They're impacted by a lot of things, like other options being considered. Once I ask for a feature, there's going to be some time before I get it. So I'm going to start looking for other ways to solve my problems in the meantime. Now, if we have long queues, I may seriously consider these other options. And this speaks to this idea of batch size that you've heard a lot about over the period of the last couple days. The other thing that happens is this idea of tacit knowledge or idea transformation. So when somebody asks for a feature, when somebody has a business problem, they describe the problem. A day later, 3 days later, 4 weeks later, that idea, that the way they envision that problem is a little bit different in their mind. So the value to them of the solution can go down. The way we look at the utility, we can wrap this all up and actually look at utility in terms of depreciation. So what we're going to say is that from the moment I state an idea, from the moment I put that idea on the shelf, it starts depreciating. There's a small time where that idea stays fresh, that feature stays fresh, and it turns out that's about 1 to 4 weeks. Anything after that, it starts to decay. Right? You actually start to run into problems with the depreciation actually kicking in and us battling that depreciation. Let me just back up real quickly here. If you think about products that have been on the market, they have a certain lifetime where people are willing to pay money for them. Think Windows 3.1. After a certain amount of time, they go to zero. Nobody's willing to pay for them. That's how you can kind of keep this idea in your mind. There's a lot of good economic theory behind this, market studies behind this. This is a very typical depreciation curve that we would think about in terms of future depreciation, where there's a little bit of a flat part at the top of the curve. So how we can actually look at this in comparison with longer cycle projects versus shorter cycle projects is that we expect this target value, we expect this freshness level. Long cycle, we probably miss it a little bit, but we come close. And as we fight that depreciation with gap analysis and future releases, minor releases, it's always a struggle till the point down at the bottom there where we give up and we go, okay, we got to rewrite the product, let's go to the next version. Right? You've all probably faced that. In contrast, Agile will release quicker, but less value, less things, less features than a traditional approach, but we're going to release more frequently. So, anybody that's taken a calculus class, an economics class, value under the curve, area under the curve, we see more value under the curve in shorter cycle projects. So that was all impact on revenue. The next thing we're going to look at is this combination of impact on revenue and cost. And we can kind of roll this all up into an idea of risk curves. We know that the longer we wait on something risky, whether it be invalid features or bugs, we're going to see exponential growth. So what we hope to do is reset that curve repeatedly. We're going to drive it down. Hope my laser pointer works here. This is the pattern that we want to see. We want to get to we let it grow a little bit, 1 to 4 weeks, and then we want to replan. We want to reset our batch. We want to reset our planning, and we want to keep these areas very, very short. We don't want this big area happening like in a traditional project. Feature validity. 80-20 rule, right? We build all these features. Some of the features we release to the market are not going to be needed. They're not going to be used. They're going to be invalid features. They essentially are going to be equivalent to waste. We can think of this as a utility value of 0. Bug cost. 2 things we look at: number of bugs, right? How many bugs are actually being generated, and how long does it take for us to fix these things? Unchecked, the number of bugs can grow exponentially. And I've worked in a lot of organizations that work long cycle, and their testing may be 6, 8, 10, 12 weeks out before they actually start looking at quality. There's no testing that's actually happening. And so what happens is you create exponential growth of bugs, which will then push your time to fix up. Bunch of great articles out there. I've blogged on it. Shoemaker talks about it in his book 2004. It's actually a .NET book. References at the end of this deck that you'll be able to get at on your USB drive. Batch size. How many people understand the concept of batch size and Little's law? Okay, 1 person, 2 people maybe. Link this for the purposes of this presentation. You can link this to the concept of utility. So if we don't let our features go stale or we keep them fresh, it will by nature keep the batch size small, and we don't really have to worry about batch size. We know that they're going to be small. Once we have to start analyzing that, just know that the longer the customer has to wait for something, the less value they're going to place on it. And it may even go to 0. All right, so those are about halfway through already. Those are all the main pieces that we're going to use to look at this case study. So simple website. We want to get it up and running as soon as possible. Some principles we're going to use. Bugs cost more the longer we wait. Requirements change. Some requirements are wrong, right? 80-20, invalid features. Software depreciates, and we can choose when to stop developing. We can stop developing at any time. We're going to take a team of 6 developers, and we're going to include everybody on that team. So this is the way I can level set an Agile project to a traditional project, is just by basically saying we have a team. I don't care how we're using them. We have a team. 4 software engineers, a DBA, a quality person. Each of them costs $2,000 a week. My run rate is $12,000 a week. 120 requirements to start with. I'm given a requirements deck. 20% of my requirements are invalid, and I'm getting 2 changes a week. How many people think so far that this is a typical project? Way too nice? What else? What other comments do you guys have so far? Developers finding or actually putting 4 bugs a day into code. Am I still nice? Mean? Easy on the developers? You guys can't hear me? Per developer, each developer generates 4 bugs a day. Reasonable? Somewhat reasonable? All right. High? Who said it was high? Okay, fair enough. Okay, we all have good developers, right? Well, maybe we can say that they're generating 2 bugs a day. I'm actually show you next, the next slide. All of these equations are available to you in a workbook. You can download this in a moment when I give you the URL. You can put however many bugs you want per developer per day and look at how the model works for you. What we're going to say is the longer bugs stick around, the more they cost to fix. For the first 7 days, they take 15 minutes. First 30 days, they take 30 minutes. And thereafter, they're going to take 90 minutes. So the purpose of this is to model some of the things that we see in the industry and try to compare short cycle, long cycle, agile practices versus more traditional long cycle, uncontained risk practices, and just see how they compare. So there's the workbook. If you guys want to jot that down, feel free. Like I said, you can play with this model and put in your own team sizes and numbers and see how it all works out. Look at the equations. You'll certainly get this deck afterwards. So what this comes down to when you plug all these numbers in is it's going to cost us about almost $500,000 to develop in a traditional sense with discovery and estimation, implementation, fixing bugs. What you should pull out interesting here is that the bug fixing phase cost us the most. Right, $330,000 to actually fix the bugs and stabilize for a total cost of about $500,000. How many people think this is reasonable in terms of traditional projects that you've seen? Okay, good chunk of you. Agile approach, cost summary. We ran 20 weeks, and the details of this, you can see this in the workbook, but it basically took us 20 weeks. So it took us about half the time, and it only cost us $240,000 from a cost standpoint. We were keeping up with utility. We were matching utility. We were keeping features fresh. We were releasing more often, and we were adjusting to the 2 requirements that were changing every week on an ongoing basis. From a revenue standpoint, gross revenue, from a forecasting standpoint, it looked like we were going to make a lot more money in a traditional sense. But as we actually get through all the waste generated, it turns out that our revenue, less depreciation, is more significant on the Agile approach. So here's the total comparison. We generated $87,000 in waste in the traditional sense. And we move all the way down to the net income on the bottom, $144,000 versus $720,000. So I'll tell you that I tried to be very nice and fair in this model and not really reflect all of the extremes that I've seen out there. And the harder I tried, this was about as small as I could get the difference to be. And this reflects a lot of the clients that we're working with, what they're actually seeing from an economic impact. Anywhere from 2 to 1 all the way up to 10 to 1 improvement in overall net income and a reduction in waste. Any questions? I can't believe I did that in 15 minutes.
Thank you, Chad.